if u equal to 2xy, v equal to x square minus y square, x equal to r cos theta and y equal to r sin theta, then find Jacobian of uv with respect to r theta. From the previous video we have discussed about Jacobian chain rule. From Jacobian chain rule you know Jacobian of uv with respect to r theta is equal to Jacobian of uv with respect to xy into Jacobian of xy with respect to r theta. So it is given that u equal to 2xy and v equal to x square minus y square. And first we will find out Jacobian of uv with respect to xy. Then we will find out Jacobian of xy with respect to r theta. Then we multiply the two Jacobians to find the value of Jacobian uv with respect to r theta. So Jacobian of uv with respect to xy equal to partial derivative of uv with respect to xy, and that is equal to the determinant of partial derivative of u with respect to x, partial derivative of u with respect to y, partial derivative of v with respect to x, and partial derivative of v with respect to y. So first we will find out the partial derivative of u with respect to x. It is given that u equal to, in the question it is given that u equal to 2xy. So partial derivative of u with respect to x equal to 2y. So this term will be 2y. Partial derivative of u with respect to x equal to 2y. Similarly, u is given 2xy and partial derivative of u with respect to y will be equal to 2x. So partial derivative of u with respect to y will be equal to 2x. And v is given x square minus y square. So partial derivative of v with respect to x will be equal to 2x. So here you have 2x for the partial derivative of v with respect to x, and partial derivative of v with respect to y, v is given x square minus y square. So partial derivative of v with respect to y will be equal to minus 2y. So here partial derivative of v with respect to y is equal to minus 2y. So if you find out the determinant of 2y, 2x, 2x and minus 2y, then the answer will be 2y minus 2y, that is equal to minus 4y square, minus 2x into 2x, so that is equal to 4x square. So minus 4y square minus 4x square. If you take minus 4 common, then in the bracket you have x square plus y square, and x square plus y square in the question it is given x equal to r cos theta and y equal to r sin theta. So x square plus y square will be r square cos square theta plus r square sin square theta, and if you take r square common, in the bracket you have sin square theta plus cos square theta, which is equal to 1. So x square plus y square will be equal to r square. So here you can put x square plus y square is equal to r square, that is equal to minus 4 r square. So Jacobian of uv with respect to xy equal to minus 4 r square. Now we will find out Jacobian of xy with respect to r theta. Jacobian of xy with respect to r theta, that is equal to partial derivative of xy with respect to r theta, that is equal to determinant of partial derivative of x with respect to r, partial derivative of x with respect to theta, partial derivative of y with respect to r, and partial derivative of y with respect to theta. So we will find out partial derivative of x with respect to r. It is given that, in the question it is given that x equal to r cos theta. So partial derivative of x with respect to r will be equal to cos theta. So here partial derivative of r with respect to x with respect to r is equal to cos theta. Similarly, x is given r cos theta, so partial derivative of x with respect to theta will be equal to minus r sin theta, and in the question it is given y equal to r sin theta, so partial derivative of y with respect to r will be equal to sin theta, and partial derivative of y with respect to theta is equal to r cos theta. So if you find out the determinant of cos theta minus r sin theta and r cos theta, then cos theta into r cos theta, that is equal to r cos square theta, minus here you have minus, so minus into minus plus r sin theta into sin theta, that is equal to r sin square theta. If you take r common, then in the bracket you have sin square theta plus cos square theta is equal to r. In this way you can find out the Jacobian of xy with respect to r theta, which is equal to r. Now you find out the Jacobian of uv with respect to r theta, which is equal to Jacobian of uv with respect to xy into Jacobian of xy with respect to r theta. We have found out Jacobian of uv with respect to xy equal to minus 4r square, and Jacobian of xy with respect to r theta is equal to r. So the answer will be minus 4rq. In this way, by applying chain rule for Jacobian or Jacobian chain rule, we can find out Jacobian of uv with respect to r theta if it is given u equal to 2xy, v equal to x square minus y square, x equal to r cos theta and y equal to r sin theta. Thank you.